You aren't cool till you got a slide rule.
I don't think you will. I think you have plenty of things that you can actually.
Well, actually, I'm a little bit tempted because, see, most of my stuff since the storage I've got a bunch of modern scenes on my workbench right now.
PDP-8A.
Yeah, oh, this is well, I've seen the 68,000 before. Is this the, I can't read it.
Corvus Systems. Huh. Don't know Corvus Systems. Vector MZ.
That memory on it? Maybe it's a complete SBC?
I think so.
I mean, it looks an awful lot like it may have been part of a larger system, but no, it's got feet on it, like it's, you know,
Once again, I don't know that I can actually take
Classic 8088 here. Like I had at work when I first got there. After working at Apple for so long. Oh, they got a message pad. It looks like a message pad 120. The old Newton that I have. It's got the cards and everything for it.
I don't say.
Okay.
It's just a neat little.
Is this all your stuff here?
Yeah.
How much is the Newton?
100.
1.5? Okay. That 120 or 100?
It's
120, right?
It's a 120.
Yeah. It looks familiar because I have one. I used to work at Apple and I bought it when they're brand new. So
Yeah. 110.
110. Oh, okay. Because I couldn't remember if it said on the front if it says 120 or not when it's 120. Forgot if they labeled it that way or not. It's cool though. There's a funny thing people don't know about on here.
The Easter egg.
The Elvis.
Oh no, I didn't know about that one.
Yeah?
A nice bong.
Oh, I haven't seen that one. What does
Yeah,
that do?
Apparently, if you manage, if I don't know enough about this to know the
Yeah.
gestures to write
Sure.
nice bong is.
Yeah, yeah.
But apparently, if you do, it brings up because the very first Newton, there was a Doonesbury cartoon
Oh, okay.
where one of the characters was,
Sure.
trying to fuss with this and
Yeah.
whatever, and they liked it so much that they put that Doonesbury
Oh,
cartoon
interesting.
as an Easter egg.
No, there's an actual.
The Newton handwriting recognition was the butt of a big joke.
Well, if you taught it though, it's fine. I actually taught it my writing style based on all the prompts. Because graffiti sucks. The Palm Pilot, I hate when you have to do it what it wants you to do.
Right.
Computer's supposed to help you, not you help it. So when you teach this correctly, you went through the whole wizard. It worked really well. And on times it doesn't, you're in a hurry, leave it as e-ink and do recognizing later when you have time to make sure it recognized correctly. Those are two tricks that people never figured out. So even The Simpsons made fun of it.
Right.
And it's like, they didn't fucking use it right. So of course it doesn't work. And I see people's chicken scratch. I go, well, I can't read your writing either. How's a computer going to read it? So that, again, that was a marketing thing they should have fixed. They could have had an ad about that,
Right.
made it humorous, but also addressed that
Right.
you need to teach it a little bit. Don't be so lazy, and then it will work correctly. Because as long as your handwriting was in normal human values, it will work, you know? But there's an Elvis trick on here. You use the Find app. So I had the World Atlas card, whatever it was called, and some other stuff. But even without the card, I think, you use the Global Find, and you say find Elvis, and it will keep changing different cities. Elvis was last seen in this. Elvis was last seen here. It'll jump around different cities. I think it's about find Elvis, I think is the command. And it changes every time you do it. It's very funny.
Okay.
But yeah, it's not a bad price. I'm kind of broke right now, but I do have an original. I got to find it. It has a leather case. It has the light up stylus that I bought for it. There's a little fatter stylus, so the light. Because they never put a backlight on the damn thing until they went to the 2100, which is the big Newton. And then they made the E-Mates.
Yes.
And it's like, all right, you guys are going the wrong direction. Go the palm direction. More people are going to buy it, you know. So, I've worked at Apple many, many times. I've been an Apple fan since I was a kid, but I still have a lot of gripes about some of the stupid shit they do. Old modems. Ooh, Atari 400. Look at that. So 400 was basically a
Stripped down
2600 equivalent.
It was a stripped down 800.
It wasn't okay, because it plays the 2600 games.
No.
It doesn't.
No.
Oh, this is
Different
separate.
cartridges.
Oh, these are separate. Okay.
Yeah.
I got
No,
confused when I saw
no,
this
it's an
sitting there.
Atari 800.
Okay, I get it.
That is, it's the cheap seats Atari.
Oh, little guys. Okay, I see. Yeah, cartridge.
See that's why it says left cartridge.
Yeah.
Because on the Atari 800, there's 2 cartridge slots.
Ah,
and
interesting.
You put one in the left and one. in
Oh,
the
I didn't
right.
know that. I think friends had it a long time ago, but it's such a blur. I don't remember.
And here you see the Atari 400 slash.
Oh yeah. Look at that. Were you a big fan of it?
No.
No.
I mean,
Yeah, anything membrane keyboards. I have a lot of synthesizers and some are membrane keyboards.
Sort of plug-in cards, which was cool.
Oh yeah.
Yeah. So you can do memory expansion and other things.
Whoa, what's this for? Vacuum tubes.
Yeah.
What does this go to?
I think that that is a UNIVAC module.
Oh, UNIVAC.
The original.
Wow, look at that. Crazy. Kind of thing would last for hours or maybe days and have to swap it. That's what I heard about the.
Well,
Was it ENIAC or Mark I? You had to constantly swap it out.
each individual module was fairly reliable, but what happened is because you just simply had so many modules that you had a problem.
Wow, this stuff's wild. There's a little hard disk platter. It's a Cray. Is that a Cray 3? No. Cray XMP. They had a Cray here for a while on display. I'm not sure what happened to it. They also had a Babbage differential machine here. It's like a replica of a Babbage differential engine. But I didn't see it on the floor.
Oh, I don't. I believe I can get
Old hard drive there. Holy smokes. Big old hard drive. Okay, data. I used to see those in shops a lot. Printing receipts.
Now, what's the story with this right here? DeckMate 2.
Yes.
This is like a terminal, right?
No, a DeckMate is a PDP-8. A desktop PDP-8. Yeah, it uses the Harris Intersil 6120 chip,
Oh,
which
okay.
implements PDP-8E on a single 40-pin IC. And, so these will run OS 8, and they'll also run. There's a funny word WPS, I think it is, word processing system, which is a custom OS that I wrote. It's just and so the DeckMate 2s are, they have, an option of either 2 floppy disk, 4 floppy disk, or hard disk. And then this is the later version, the DeckMate 3. They dispense with the hard disk.
Same.
Same architecture, same software, same chip. Yep.
And these are all them also?
No, these so these two are VAX Station 2000s. It's a VAX, approximately a VAX 11750 worth of VAX, so like 0.7 buck. And then because it has no real expansion capacity, it's like, oh, I want a tape drive for my VAX.
I see. And you have to have a SCSI cable to go between them and all that.
Yeah, well, there's a pile of the SCSI drives are one thing. The tape drive actually uses a different connector, or rather, yeah, is not SCSI. It's its own thing. And so.
What format was the tape drive back then?
It's a TK50.
Okay.
Yeah, TK50.
TK what?
TK50.
TK50. 50, yeah.
Which is a QIC. Yeah, I mean it's.
Yeah, it's a good cable.
Almost like a Colorado kind of thing, almost. Yeah.
TU-58 for
I don't have one in the room. I probably, I have several.
You got any that are in boxes, or are they all open?
I have boxes.
No, I mean, like a cabinet. 'Cause
Yes,
mostly,
right.
when you find one, if you can find one.
It's out of like a 11750.
Yeah, it's like laying on the table with its guts all
Right,
over the
right.
place.
No, I have the enclosures. In fact, I have more. I think I might have more
Do you have any-
enclosures
do you
than
have any
tape drives.
media?
I am pretty scarce on media. Like I had a ton of it and loaned it to a friend to archive it, and so he scraped the bits off, and then he like gave away the tapes. And I'm like, that's not. How
That wasn't the
was
deal.
supposed
Yeah,
to
that
work.
wasn't
The way you do
That is
it.
not how that was supposed
Ouch.
to work. Like hundreds of tapes.
Oh my God.
And now I have like 8 tapes. So,
Yikes.
it's a CPM laptop. Yeah,
That's a CPM laptop?
yeah. Has it in ROM.
Mm.
And it was working earlier today. I discombobulated. I cobbled together an adapter, and then I had to disconnect it to power something else, and then it's like, which query was which? So I didn't watch. Stores, CPM stores programs on the tape, and it has a carry handle.
Oh,
And then you fold it up, and this one is missing. There was a plastic cover. You could 3D print one in this day and age, and then you can have your, and it had the batteries missing, but it had a little iPad battery pack, and your ROM there. CPM.
What year is that? You think?
I don't know.
I'm gonna say mid-80s.
Yeah.
Couldn't be much later than that.
Yeah, because CPM only lasted for a while, right?
Yeah,
So.
well, CPM kind of didn't make it much past MS-DOS.
Yeah, exactly. Because they stole it.
Well, there is that.
Yeah. So.
I think there was actually a legal case
Really?
on that subject. That is a cool machine.
So yeah,
Yes.
the keyboards are pretty decent, and it's like
Hmm.
little fold down feet.
Oh, look at that.
Works better if it's on a flat surface.
Yeah. Well, you have to fold down both sides.
That's cool.
Yeah. Okay, what else we got
Huh.
here?
Thanks a lot. Cool stuff.
Stuff.
It's a little language I can't read.
Oh, that's fine. So when he's okay, he's gonna do that because he's eating way too much for no reason. Take your
Let's
feet
see. Anything else showed up here?
So I've got 3 on my controllers. The next one's probably gonna have like 10.
Some different stuff showing up here. check back once in a while and see what's different. Brother. Someone bought a lot of the 8-inch floppies. Who's this guy? Is it a projector? Oh, a little portable computer. Texas Instruments with a built-in printer. Silent 700. Silent but deadly. Hazeltine 1500. There you go. There's an oldie. Portable system. The keyboard cover. What else did they? The oscilloscope is still here. That's still here. Oh, I didn't see that before. That's cool. Another quote-unquote portable. Level 2 Plus is still here with a monitor. Atari 400. Some kind of a portable computer there. It's in this wooden box. Oh shit. HP 85. Wow. That system there. Printers.
Yeah, I mean, he's not going to give us minimum doesn't want to have like I like to do the next person right. I didn't want to be doing it in a vacuum.
Mac in a Bag is still here. All the stuff is gone. All the laptops are still here. Sanyo is still here. Mac OS 9.2. Well, took the recorder out of the box. Almost Pong game. Macs are still here. SGI stuff is still here. Ring light is still here. Chromemco. Pixar. There's a camera here. These are all still here. Old Macs that nobody wanted. Oh, these little guys. E-mates are still here. These are pretty unusual. Newton OS. All right. Okay. So at the end of that talk.
But the problem is, for instance,
I like the guy in the lab coat. That's fitting. Gotta have a guy in the lab coat. Here's the homebrew guy. Let's go see what he has to say.
And shut you off. There'll be some garbage in the meantime. So it worked pretty well because we had at the Homer Club, they had several, the guy who would be credited with copying the basic tapes, he would ask during the meetings, does it work in Felton? Felton in Santa Cruz County had an ITT phone system, an off-brand phone system, as he told everybody. And you would hear impulse noise and basically other conversations on the line. His test was, does it work in Felton? He kept asking this in the police when I was telling people that the Pennyworth was coming. And the day came when he had it, and he came in and he said, it works in Felton. He was surprised. I was immensely gratified because I don't know what I would have done otherwise than to his place to debug it. So anyway, Schmidt-Trigger reference point moved enough to keep track with the speed variation, whatever the cassette was, and there's an adjustment here, but that's that's compensated for by the characteristics of the feedback. You don't really need it. I wasn't old enough to just put a resistor in this SVT or something like that. So it had a little adjustment, but that's really not a threshold adjustment. You don't need a threshold adjustment. So that meant we could sell it as a kit, because the hard thing about modems is the adjustment. So this is the detailed explanation of what I just said for the reference. And the line break constraint. When you went to a line break condition, which would be a space condition, in telegraphy, the whole circuit is a series circuit, out the wire and back. Telegraph keys have this little switch, a lever that will short the key out. That's where you normally leave it, because all of the additional traffic from the line is going through that key and down the line. And so when you get a line break condition, when the line goes down, that is a failure condition. And in this case, it can happen very easily. The terminal gets turned off or something like that. So if you slow down the data baud rate, eventually that space will get so long that the capacitor will charge up past wherever it has to be, and it fails. And so I did some calculations here. Anyway, that's move that up. I'll read her off the paper. I got the calculations here, you'll see it on the slide, when you can see the slide. And the minimum baud rate is approximately 10 baud. 10 characters, not characters, 10 bits per second. So there's a lot of room in this. Whoops. It's got to rotate at 90 degrees and stretch it out. Okay, well, I sure hope to do that. I can fix this right now. The point of it is there's an output from the filter gets AC coupled, and we do a carrier detect. There's a circuit that, if you look sideways at this, it's an AC couple coming in here. Putting a diode across the feedback resistor means you have a halfway rectification. So it can't go up, it can only go down. in response to the current coming up here. That little capacitor here that smooths that out a bit. Then you have a big capacitor, that's the 1 microfarad. And this will slowly discharge because of this resistor to the point where this amp operating as a comparator decides, oops, it's crossed the threshold, I'm going to go from all down to all up. And that's the carrier detect signal. So let's just move past that. There's the literary description of the carrier detector. Which I just localized. I'm going to move past that. And here's our data transmission path. Here's your data input. Pin 2 on the connector is RS-232 data. These two pins, 12 and 13, are current loop data. So if you want to use the current loop feature of the teletype, that's where you're connected. You've got 4 diodes in the form of bridge. You've got an optical isolator, so you don't care what the voltage is out here, just what the current is. The current will cause the LED inside to illuminate on the phototransistor. You get up to 1500 volts isolation. You're safe. And both of these sources of data, one after the other, come into a transistor. This is a Schmidt trigger circuit for those who recognize it. Your feed back here, but not enough to hold it in one condition. So that squares up your signal. And so what comes out of here is a data coming in, shifted from the RS-232 bipolar levels or from the current loop. And there's your literary description of what I just said. And here's a transmit oscillator. You've got the output transistor of the Schmidt trigger shown over here. And now you have some networks, some voltage dividers that can be switched between high and low, the originator and its frequencies. They're just providing a DC voltage here in accordance with what the data is. So the data will cause that by cutting in these resistors that run in parallel with the potentiometers. I mean, they both have potentiometers. It will cause the voltage at the base here to move between two levels. These diodes are there for temperature compensation. And that includes this. So what this does is, this one, the transistor Q6, causes the current to flow based on that voltage. It's an emitter follower. The emitter resistance is R66 and R67. And notice that there's an old 1K resistors. Resistor and a collector. Same current flow through that as flows through the emitter. So that produces a voltage, nominally 1 volt. And it shifts with the data. So as your current gets higher, each voltage becomes greater across these resistors that are in the base and intersection of Q7 and Q6. Q7 and Q6 have their emitters go to an emitter following resistor. So voltage in the base to emitter, will then result in a current determined by the emitter resistance. Now that's 1K for the pull-up version on Q6, and 1/2, 500 ohms, generated by parallel with 2 resistors for the pull-down version, Q7. Now what's the point of this? Well, let's feed the current to a capacitor, C20, 21. So if this transistor is turned off, then this current will cause a linear ramp on the capacitor will charge CdVdt, for those who understand. So it will charge up. When this transistor turns on, drawing twice the current that this one is. Remember, this hasn't changed, it won't change. Then it swallows all current provided by Q6 plus an equal amount. So that gives you a negative going ramp on the capacitor. 555 timer circuit here has two thresholds, which are basically at 2/3 and 1/3 of the supply voltage. In terms of divider, there's 12 volts here, so that's 8 volts and 4 volts. So the voltage of this capacitor, when it exceeds the high threshold, there's a latch inside here that says the output should turn off. And pin 7 clamps on. It's an open collector circuit that pulls down. And that will pull down here and turn this guy off. So that basically turns on this transistor. Remember, I said it turns on and off. Well, the data isn't doing that. But the data varies much more slowly than this does. This produces the 1070 and 1270 hertz, or 22 or 25, if I can remember right. So when that turns this, when this pin 7 goes down, this die blocks the pull-down transistor, turns on, and causes the ramp to start moving downwards until it reaches the low threshold, 4 volts. When it all reverses, the internal latch changes. It's pin 3. There's pin 3. Yeah, that's here. I'm wearing my close-up glasses. So that provides a square wave at the intended frequency, and that intended frequency will change based upon this voltage here, which is dependent upon this network or that network, and depending upon whether you're in a high or low mode, and depending upon the data. So we're using a simple timer circuit, timer chip, producing square wave, which is symmetric enough. It's supposed to be hard to use the generated square wave for these chips, but that's if you don't do any circuit design. Just copy circuits from the book. But this is one way to do that. And there will be some asymmetry based upon the ratio of these resistors to this resistor. Okay. There's the narrative description. So we'll gloss over it. Didn't happen this way. Fortunately, these happen when we have simple circuits. Here's the 555 output. Just turn your head sideways. And here, this point is connected to the capacitor. So it's AC coupled through this capacitor, high impedance. We have a bridge T filter there. And all that does is take this the linear ramp and kind of add a little sort of exponential characteristic to it. So it's kind of sanding off the point to it. And thus that removes some high frequency components. This removes more of them. We send that out as the audio, which goes to a speaker. We're actually using two speakers, one of which pick up the audio from the phone, and the other one is to transmit it to the carbon microphone as phones used back then. Now I did some tests, and based on signal generators, I could get a good response from a minus 50 dBm signal, which is rather slow. It's way down there, put it that way. And when I did use it on a phone, I couldn't do that. It turns out that I was limited to 35 dBm, so I wasn't as sensitive as I thought I was going to be. And I got myself a poster of a train wreck of somebody saying, "Oh crap," to remind myself, and I hadn't quite succeeded here. So that's what it is. That's the specification. It's basically the carbon microphone that provides enough distortion. So there's a simple description of what I was trying to say. And so that's our audio output. On the next slide. Those wooden box modems, they were priced around $350 because this was not a consumer product. This is a product used by computer professionals, big data centers and things like that. However, now, I just tell you how we got from 1973 to 1976. I find the site from waiting 3 years. The Home Computer Club started. Marty Spergel was an original participant. He called himself the junk man. Because he would get a little business going, M&R Enterprises, the artist Roman and his wife. And they would bag up little boxes, little kits of parts for construction projects that were published in Popular Electronics. So he had a good relationship with Popular Electronics and Les Solomon. So he came to me and he said, "Give me a design to manufacture." I was talking about this conceptual design, Tom Swift Journal. He says, "What do you want? Give me that design and I'll manufacture it." Well, it's not ready. It actually turned out never to be ready. But I said to him, "You know what you can do? I have this design that's been debugged and it's been operated. We used that motor for about a year on a community memory system." And one was as good as the other as far as he was concerned. So he went ahead and productized it. I mean, I did the design of the layout of the circuit board. He did the mechanical design. He had people do it. And he found the parts. He found the rubber cups in a warehouse somewhere. And that's what a junk man can do. I wouldn't have had a clue where to get them. He found them. I worked with him to help write the manual. And he put that on the market in 1976. It was on the cover of the July 1976 Popular Electronics. The initial price was $99. He quickly raised that to raised it to $139. I changed that at the last minute, but that version didn't get here. And so that $139, you could get a modem. You had to build a kit. It cost $225 if he built it. But it was simple enough to build. Plenty of people did. And if it didn't work, you could send it to Marty and he would have some people debug it. And if you couldn't get an adjustment because it needed an oscilloscope to do the adjustment right, you could send it in. His techs would do it. This was all operated out of a garage I was making $10 a unit as a royalty. I don't remember what the numbers were, but it was 7,000. And I was happy because he wasn't bothering me. Unlike Osborne, that's a different topic. Okay, so Pentecostal Red survived as a product until 1979. I guess at this point, I have another presentation on the Kansas City tape standard. Is anybody expecting that? Because otherwise it's open for questions. Let me see if there are any questions here.
All right. If you have questions, I'll come to you.
We have a hand.
Actually, my first question is going to be, how much did any of the work on Penny Whistle Run-Free feed into the Kansas City spec? I actually was...
Okay, I'll talk about that. Kansas City meeting was organized by Wayne Green in November 1975. I attended along with many other people from different companies. We each had our little product to push. I was pushing the Penny Whistle. MITS had a 103 modem with no adaptive reference. But Don Lancaster had published an article in the first issue of Byte, which was 1975. I can't remember the month here. I didn't talk somewhere. And he made an important advancement. He looked at the UART, which requires a receive clock at 16 times baud rate. He said, what if we recorded the data on the tape with a carrier that's 16 times the baud rate? So that's 4,800 hertz for 300 baud, which would shift between that and 1/2 that with the data. And so you can recover the clock from that, either by just looking at it if it's 4,800 hertz, or doubling it if it's 2,400 hertz. There's simple ways to do that. And if you do that, you now have a synchronous receiver that tracks whatever the tape speed is. And it really is brilliant. I wrote an article on that in People's Computer Company. I did a participatory design feature. And a guy named Harold Walsh, M-A-U-C-H, his company was Percom, I believe. He's in Texas, I think. Was one of the respondents. So basically, we went through like one cycle of here's an idea, here's my solution, here's what I think of it. He showed up at the Kansas City meeting. So basically, the Penny Whistle design had no real effect on the Kansas City standard, except for my own experience and proclivities and the fact that I had already written about Lancaster's design. We couldn't do Lancaster's implementation on an existing personal computer because they would have the UART circuitry already built in and using a constant clock. And had we been able to implement that, things would have gone a lot better for set data, I'll put it that way. So the only effect of the Penny Whistle design on the Kansas City design was to incentivize me to push the whole point that you do have to take care of the speed variation of cassettes. So that's the answer to your question. It's like, I would still like to see the Lancaster version with variable receive clock implemented on the UART. Since I'm so familiar with the solid design where we didn't make that receive clock variable, I would like to upgrade that someday and see what kind of performance we can get out of it. It's almost irrelevant because nobody's using cassettes anymore. And, you know, I saw the cuts design. I refused to do that. Certainly that channel design, Bob Marsh did it himself, which I have my reasons for that. But he used the fixed lock loop. And if we could have inserted a 4-bit counter in the feedback loop and had jacked it up by 16 times, we were very close to it. But then we would also have had to make the receive clock switchable between internal and external. It would have worked. Any more questions? We have one here.
I just have a very simple question. Where did the name come from? I'm guessing it's because the low cost and audio tones, the modem.
And I was born and educated in Philadelphia. So we learned all about Benjamin Franklin and the story of him being shamed by having spent something on a penny whistle rather than something, you know, substantial. Penny saved is a penny earned, or whatever. So, have I actually ever encountered a penny whistle? I doubt it. I've heard people play them. That's about it. So, that's where the name came from. In amateur radio, a low power transmitter is often called a peanut whistle. That was my first idea, though. It's a very small tone generation thing, so peanut whistle, but not too many of the people involved were hands, and I quickly changed it to penny whistle. I've seen it done that. I hope we can get some bets on that. Have there any more questions? Okay. Well, I'll be here if you want to talk. I apologize for the sideways schematics and stuff like that. That's, goes along with these little question mark bullet points. Everything's equivalent. I store these files as PPT, PowerPoint, but I did them as ODP, which is Open Data Presentation. There's obviously some very slight differences. We saw it here. All right, thanks for coming.
All right, thank you, Lee. So eventually the talk will be available on VCF's YouTube channel, as well as his slides with a link to that. So today, this officially ends activities for today. We do have food trucks coming out. We're going to be eating on the patio. So everyone's welcome to come to that after the show. So thank you. I'll see everyone tomorrow at 9 o'clock.
Okay, guys, with the food trucks coming and this talk's ended, I think that's it for the day. If you're still here or you just showed up, please check out tomorrow. See what I already posted today. I think I got 3 or 4 videos up already. And since signal works around the whole building, which is rare these days, I'll be doing more lives tomorrow. Not as extensive because I covered a lot of stuff, but I'll be shooting some more stuff. So thanks for hanging out, and come back anytime, get your geek on. All right, see ya.